In this video, we're going to talk about the laws of exponents. So you've seen the laws of exponents. You first were introduced to at least some of them in Algebra 1, and then you probably saw them again in Algebra 2. And so we're going to revisit them quickly here. So this says that if you're given two powers with the same base, two exponential expressions with the same base that are being multiplied together, then you add the exponents. So for example, if you had something like 2 to the 4th times 2 to the 7th, this would be the same as 2 to the 4 plus 7, or 2 to the 11th. And that's this first property. This second property says that if you have two exponential expressions that are being divided and they have the same base, then you take the difference of their exponents. This one, it's key to remember that when you're taking this difference, the numerator's exponent is first in the difference, so it's the numerator minus the denominator. This one says if you raise a power to a power, then you take the product of the exponents. So if you had something like 5 squared, all of that to the 5th, this would be equal to 5 to the 2 times 5, which is to the 10th. So that would be 5 to the 10th power. This is saying that if you have a product, a times b, all of that being raised to some power s, then this power basically gets distributed into each of your terms. So it would be a to the s times b to the s. And then in this one, a negative exponent. Negative exponents are often the ones that are going to trip up people most of the time. A lot of times we think that this makes our base negative, but in fact what it does is it actually gives us the reciprocal of the base. So a to the negative s is equal to 1 over a to the s. Or you could think of it as being the entire quantity, the reciprocal of our base, raised to the s power. And this works both when it's in the numerator and the denominator. So if you had, for example, 3 to the negative 2 power, we could say this is the same as 1 over 3 squared. So essentially you can kind of think of negative exponents as causing our base to move either from the numerator to the denominator or from the denominator to the numerator, and then you just evaluate. And then you make this exponent positive and you evaluate. So this would be 1 over 9. But you could have something similarly like this. You could have, let's say, 5 over 2 to the negative 3rd power. Now, if you're evaluating something like this, and you see this 5 here, its power is a 1, so it actually has a positive exponent, so it's not going anywhere. So the 5 is going to stay in the numerator. And then this negative 3 is going to move this into the numerator. And when we do that, these two we'll take the product of these two. So it's going to be 5 to the 1st times 2 to the 3rd. And then you would just evaluate that. So that's 8 times 5 would be 40. So that's what negative exponents do. This law says that if you have any base raised to the 0 power, it's 1. And this says that 1 to any power is 1. And these are the laws of the exponents. And we're going to use these quite a bit, not necessarily to directly solve problems, but in problems you'll see and have to apply these different laws of exponents.